Good day. This video presentation is for Calculus 1. I'm Arvy Almine from BSCE 1A. The first one is the implicit differentiation. There are two steps in solving implicit differentiation. First one is differentiate both sides with respect to x. Second one is isolate all dy over dx terms on the left side. We have here the example number 3. Y is equals to x squared y plus y squared x. So let's get the derivatives of x squared y plus y squared x through product rule. So the derivatives of x squared y is x squared dy over dx plus 2xy, and the derivatives of y squared x is y squared dx over dx plus 2y dy over dx and x. So let's simplify the right hand side of the equation using chain rule and product rule. We have dy over dx is equals to x squared dy over dx plus 2xy plus y squared plus 2y dy over dx and x. Let's rearrange the terms to isolate. We have dy over dx minus x squared dy over dx minus 2y minus dy over dx x is equals to 2xy plus y squared. So we have dy over dx minus 1x squared minus 2yx is equals to 2xy plus y squared. So let's remove this right left side through dividing 1 minus x squared minus 2yx. So the left side will be cancelled. The dy over dx is equals to 2xy plus y squared over 1 minus x squared minus 2yx will be the remaining. So that will be the answer of the number 3 example of the implicit differentiation. The next one is the higher order derivatives. So we have here the example number 16. Y is equals to x plus 1 cube square root of 3x minus 5. To find the higher order derivatives of the given function, we will use the product rule and chain rule repeatedly. First, we can simplify the function by expanding the binomial and writing it as y is equals to x plus 1 cube times 3x minus 5 to the power of 1/2. Now we can find the first derivative using product rule and chain rule. So we have 3 times x plus 1 squared times 3x minus 5 to the power of 1/2 plus 1/2 times x plus 1 cube times 3x minus 5 to the power of negative 1/2 times 3. So by simplifying this expression, we get the first derivative of 3x plus 1 times x plus 1 squared times 3x minus 5 to the power of negative 1/2. So to find the second derivative, we will need to use the product rule and the chain rule. So we have the 6 times x plus 1 times 3x minus 5 to the power of negative 1/2 times x plus 1 squared times 3x plus 1 times 2 times x plus 1 times 3x minus 5 to the power of 1/2 minus 1/4 times x plus 1 cube times 3x minus 5 to the power of 3/2 times 3. So by simplifying this expression, we get the second derivative, which is the 18x squared plus 18x minus 47 times 3x minus 5 to the power of negative 3/2 times x plus 1. So finally, to find the third derivative, we will need to use the product rule and the chain rule once again. So we have 54 times x minus 1 times 3x minus 5 to the power of 5 half times x plus 1 plus 8nx squared plus 8nx minus 47 times negative 3 half times 3x minus 5 to the power of negative 5 times x plus 1 times 18x squared plus 18x minus 47 times 3x minus 5 to the power of negative 3 half. So by simplifying this expression, we get the third derivatives of the problem, which is the 27 times 5 minus 9x times x plus 1 over 3x minus 5 over to the power of 5 half. So that's how we get the higher order derivatives of the number 16. Next one is the maxima and minima. We have problem 607. An open top rectangular tank with square bases is to have a volume of 10 cubic meter. The materials for its bottom is to cost 15 pesos per square meter, and that's for the sides. 6 pesos per square meter. Find the most economical dimensions for the tank. So we have, let's see, equals to total cost. C is equals x squared times 15 plus 4 times x h times 6. It will give us the answer of 15x squared plus 24xh. We have v is equals x squared h. Tan is equals x squared h. Divide both sides by x squared. It will give us the answer of h is equals to tan over x squared. Substitute h to c. C is equals 15x squared plus 24xh. Replace h to tan x squared. Multiply this 24x squared times tan over x squared. It will give us the answer of 240x squared, and divide again by x squared. It will give us the answer of 15x squared plus 240x to the power of negative 1. Then in this area, let's perform derivative using power rule. So 2 times 15 x squared minus 1 plus negative 1 times 240x to the power of negative 1 minus 1. So the derivative of this one is 30x minus 240x squared equals to 0. And let's move this 0 into the left side. We have 30x minus 240x squared, and then let's remove the 0. We have 240 over x squared equals to 30x, and divide again both sides by x squared. We get the answer of x cubed equals to 240 over 30, and x is equals to 2. How do we get x is equals to 2? So x cubed is equals to 240 over 30 from the problem. So to solve the equation x cubed equals to 240 over 30, we can simplify it by dividing both sides by 30. So we have x cubed over 30 is equals to 240 over 30 over 30. So to get rid of the fraction of the right side, we can multiply both sides of the equation by 30. So 3 times x cubed over 30 is equals to 3 times 240 over 30 by 30. So this implies this simplifies to x cubed. So let's remove x cubed from this area through performing cube root cube root of x cube equals to cube root of 8 will give us the answer of x equals to cube root of 8. So evaluating the cube root of 8, we find the x is approximately equal to 2. Therefore, the solution to the equation is x squared is equals to 240 over 30 s x is equals to 2. Now, let's substitute x to h. H is equals to 10 over x squared. H is equals to 10. Then, let's put 2 to the x. We have 10 over 4. Now, let's divide this 1. 10 divided by 4 divided by 10. We have h is equals to 2.5 meter. The dimension of the tank is 2 meter by 2 meter by 2.5 meter. Therefore, the most economical dimension for the tank are x is equals to 2 meter, h is equals to 2.5 meter, resulting to the correct answer, option B. This is how we solve the maxima and minima. So the last one is the time rates. We have heard the example problem 612, ECE board November 1998. Given a cone of diameter x and altitude of h, what percent is the volume of the largest cylinder which can be inscribed into a cone to the volume of the cone? We have let r equals to radius of the cone and the small letter r radius of the inscribed cylinder. H equals to height of the cone. Small letter h is equals to height of the inscribed cylinder. We have v is equals to pi r squared h. By ratio and proportion, r over h is equals to r over h minus h. hr minus is equals to rh minus rh. H is equals to rh minus hr over r. So substitute h to v, we have pi r squared h. So pi r squared times rh minus hr over r, we have pi r squared h minus pi r cubed h over r. So perform derivative. dv over dr is equals to 2 pi rh minus 3 pi r squared h over r is equals to 0. So let's move this one. So we have 3 pi r squared h over r equals to 2 pi r h. So we have r is equals to 2/3 r. So substitute r to h. H is equals to rh minus hr over r, and h is equals to rh minus h 2/3 r over r. We have h equals to 1/3 h. So substitute r and h to v. We have v is equals to pi r squared h. V is equals to pi times 2r over 3 squared times h over 3. So v is equals to pi times 4 over 27 times r squared h. Let VC volume to cone. VC is equals to 1/3 times pi r squared times h. VC is equals to pi over 3 times r squared h. Our ratio is equals to V over VC. Our ratio is equals to 4 pi over 27 over pi 3. So if we solve this, we get the answer of 0.44. So 0.24 times 100, we get the 44%. That's all. Thank you. God bless.
Show you off in Lambos out on Collins. I be